Um, Today, we have a very special event, a joint event between the Universiti Putra Malaysia, Faculty of Aerospace Engineering, together with Malaysian Society of Engineering and Technology. That we are so fortunate that we are able to invite basically a representative from Boeing Aircraft Company Asia Pacific. And to me, this is a very special occasion where we are able to hear from a leader, from a person, a representative from a company which is actually a leader in the global aerospace community. As of date today, if you are not aware, up to today there is more than 13,000 patents, yeah, aerospace patent that has actually been patented by Boeing. And Boeing has always been the leader of innovation in aerospace industry. For example, Boeing built the first commercial successful jetliner in the world, the Boeing 707. That was actually one of the first Boeing very successful commercial jetliner. And the Boeing 727 also holds the record, the first jetliner to actually surpass the 1,000 sales, 1,000 aircraft sales. And even more, the Boeing 737, the Boeing 737 family, it is actually the first jetliner to actually surpass 10,000 sales as of today. I mean, as based on the record as of today. So can you imagine just the 737 alone in the world, there are more than 10,000 737. And it is also the first wide body jet manufacturer, especially with four engines, the Boeing 747. It is a very successful model designed by the Boeing. And even more, as they progress, this is what Boeing actually has proven again and again. They are the leader of innovation. And the first jetliner developed entirely on the computer. Developed entirely on the computer. It is actually the Boeing 777. The Boeing 777 is still flying around, a lot of them today. And the first jetliner to be assembled mainly from the composite materials, yeah, primarily from the composite materials. It is the Boeing 787. So Boeing actually is formed in 1934, and it has a very long history. And to achieve as what it is today, one of the greatest innovator in aerospace industry. And today we are so fortunate that we were able to invite Mr. Adrian Tan to come, and share with us, uh, the innovation in aerospace, as the integral part of the daily activities, especially I believe in the aerospace industry and as well as in Boeing. And Mr. Adrian is a very young gentleman. I came to know him in our same society because of an article that he wrote. That article really attracted me that I started to communicate with him. And hopefully, I was actually hoping at that time to invite him to give and share his knowledge to the students, especially for UPM. Many of you are aerospace engineering students. You have a good example here what an aerospace engineer could be and how he can achieve what he achieved today. Now he has a slide that will introduce his background. I'm not going to touch so much on his background, but welcome, Mr. Adrian Tan, and may I hand over the mic to you and take over the floor then. Thank you, Mr. Adrian.
Hi, thank you, Ricky. Hi, good morning, everyone. Indeed, it is my great pleasure to be speaking to you guys today from Singapore. Right, let's go to the next slide. Okay. Okay, hope that you guys are seeing the slide move. Ricky, is it okay?
Yes, it is okay.
The slide are clear, yes.
Okay, thank you very much for the confirmation. Now, before we begin, I would like to thank myself as well as UPM for this opportunity to share. Honestly, guys, this is the first time I'm doing a webinar delivery and also speaking to international audience like yourself. And great thanks to Ricky again for extending this invitation to me, as well as kindly volunteering to be the moderator for this event today. Right. At this juncture, I would like to say that this is not a lecture, but a sharing of my experience that I've accumulated from my work experience, right? Both from the Boeing company as well as the Republic of Singapore Air Force. Right, just a bit about myself. I guess that this slide comes in especially important in a webinar like that because we do not have a face-to-face interaction. So that's just a bit about myself. I'm Adrian, right? And something that is very special today is that although I'm a Singaporean, my dad actually comes from Malaysia, the state of Selangor. And I've been visiting Malaysia all these while since I was young. And that holds a very special bond to me, right? Of course, currently we are faced with the COVID situation and certain visitation to my paternal family have to be deferred. So I guess everybody is facing the same issue, right? And I hope that we can ride through this together safely, especially for the aviation industry. Right, I'm also a passionate aerospace engineer, like everyone here, who wants to contribute to the industry and to make great machines fly. I have a Bachelor of Engineering from Aerospace Engineering from NTU, as well as a Masters of Science from from the Mechanical Engineering Faculty of NUS, both universities in Singapore. This is not a paper chase to me, but to me, knowledge is key. Knowledge allows us to push frontiers, and having a continued education plan allows us to do that. I'm also an incorporated engineer with Engineering Council in UK, right? And seeking professional accreditation or registration to me is a guideline. I'm working towards a chartered engineer, and within that framework, it allows me to go in the correct direction. So at this juncture, for those who are not professionally registered yet, I strongly encourage you to do so because it moves you to the correct path. In terms of work, I have 7 years of work experience. The first part was with the Republic of Singapore Air Force as a uniform engineering officer. Right, that was 5 years again. Right, during which I hold a concurrent appointment of productivity and innovation in daily efforts secretary. So what this role requires me to do is to drive innovation within the Air Force, especially amongst the engineering corps, right, which is very pertinent to the presentation today. Right, I'm currently with Boeing Asia Pacific Aviation Services, like what Ricky has mentioned, as a maintenance programs engineer. I am the maintenance programs engineer for the 787 fleet in Singapore, right, for one of the low-cost carrier here. And I've been with the company for 2 years, during which I led some innovation projects in the company as well as the project lead. So that's a bit about myself. Right, as with many presentations, this is a bit of citation, right? I'll be using pictures taken from the internet. Some of them are proprietary, and some of them are used to actually deliver a message across because the actual picture may not be able to use because of sensitivity issues. So these pictures that we are seeing today are actually copyright of the respective owners, and if you want to duplicate them, right, do use it with caution. Right. Okay. So before we go into the content proper, right, I would like to start the presentation with a quote. This quote is particularly special to me because I saw this quote when I was in Seattle, the headquarters of the Boeing company, when I was there for a work trip. Right. So William Boeing once said, right, we are embarked as pioneers upon a new science and industry in which our problems are so new and unusual that it behooves no one to dismiss any novel idea with the statement that it can be done. Right, so I highlighted a key few points here. Right, aviation is indeed a very new industry as compared to other established industry like the automotive industry or the maritime industry. Right, And to have a 270-ton machine take flight, so unusual, right? Without any form of support. Of course, in current days, we know the science and physics behind it, but it is still relatively new and something that you cannot really visualize, unlike the other industries, the more common industry. So in order for us to push frontiers in this industry, as well as to solve problems that will be very novel and unique, right? We cannot dismiss any form of ideas. And continual transformation in this industry, right, can only be done through innovation. So William Boeing indeed has the foresight to see how we should develop this industry. All right, so now that we have gone through the first preambles of stuff, we could kind of go into the actual presentation proper. I would like to start with the definition of innovation. Right, so of course, when we do not know what a particular thing means, we go straight to the dictionary, right? And according to dictionary.com, innovation is to, or rather to innovate, is to introduce something new or make changes to anything established process, a process that you have been using. Now, more in depth, right? Innovation can be an adaptation of methodology. This methodology may be used elsewhere in other industry, perhaps, right? So you are trying to move this methodology into the aviation context for use, right? And it also can be something new, right? Especially in the recent times, we see a lot of new stuff coming up. Things like, the sawtooth shaped nacelle that you have on the newer aircraft, the Boeing 787, as well as the Airbus A350. These are something new. And I would say that, these are the bigger things. These will be more challenging in nature, right? So, pertaining to point 1 and 2, right? Innovation, the idea, the product of innovation can be something tangible. You come up with a new equipment, right? A new product, or it can be something that's intangible, like a process change that you are effecting on a existing process. Before we go any further, right, I would like to have you keep in mind this particular statement that I have at the bottom of the slide, right? Aviation is a very highly regulated industry, right? And it is so for the very reason of aviation safety. In aviation, we talk about repeatability, we talk about compliance, we talk about adhering to standards, qualification and certifications. These are really indeed required for safety and continued airworthiness. So this, under this context, innovation and standards or qualification may be counterintuitive in the practical sense, because people would think that certification of or current regulatory processes may kill innovation. But what I want to bring across is that innovation still can happen, right? And innovation must be used in a qualified manner. And these regulatory processes must not kill innovation as a whole, and it shouldn't if it's used properly, right? So, looking at the current context, what are the things that are new for aerospace in the last 10 years, right? This list is non-exhaustive, but these are things that are closer to me, closer to heart, right? Like I said, I had a specialization in additive manufacturing, which is 3D printing. So one of the innovation or new idea that we see here in aerospace in the past 10 years is the application of 3D printing on aerospace parts, right? On the bottom left-hand corner of this slide, you see that we have a fuel nozzle used in a LEAP engine. This is a GE CFM initiative that is 3D printed. The wonder of 3D printing is it allows complex geometry, such as an engine swirler cup, or for this case, a fuel nozzle, that to be manufactured that is not possible with a conventional manufacturing process. Now, because perhaps within the internals of this swirler cup or geometry or fuel nozzle, right, you if you were to use conventional processes like casting, right, there will be areas that you can't really cast because you won't be able to disrupt the mold after casting. So 3D printing actually allows this gap to be bridged. The next part that we see in aerospace that is new is this part about augmented learning and augmented maintenance process. In the center of the picture, this is a real life picture, right, that is applied to RSAF, whereby technicians can use augmented learning. Basically, you see the goggle that this technician is wearing, right? It superimposes information or parts of the manual as when he's looking at the actual object itself, the aircraft. So under that consideration, learning becomes more interactive, and for maintenance of aircraft, right, you could kind of get more support if that systems allow you to do so, to actually tell you which are the items that you should be looking at in relation to the manual. Lastly, we also see a lot of robotics intervention or robotics infusion into aircraft maintenance and ground support function, right? Just last week, the Civil Aviation Authority of Singapore, right, granted the rights or license for ST Engineering, ST Aerospace, for using a drone to do an inspection on a A320 aircraft. So with the introduction of robotics, right, it makes things less human intensive. It makes things faster because of the reach that these devices can give. So indeed, within the past 10 years, or since 10 years ago, we are seeing a lot of new things that are actually being inducted into the aerospace industry. All right, next. So now that you know that what are certain things that we will be looking at, we talk about your role in innovation for aerospace industry. So before we go into the case study and what you could kind of do for aerospace industry in terms of innovation, right? There are three preambles that I like to share. I guess most of you, or if not all of you here, are engineers, aerospace engineers, be it whether you are making your way into the industry or if you are taking a course in it now, right? Let's face it, engineers are lazy, not the inverted comma, right? Right, because honestly, when we are engineers, we know the subject well, we understand, or rather we want to understand, or we seek to understand a particular subject. And because we seek to understand, we will know something well, factually, and we always would seek the easiest way out correctly, right? If we know that what we are doing now at its current state or process is not the most ideal. So honestly, with this idea, it makes engineers very good innovators, right? And all right, so the next point is the question about the magnitude of innovation. A lot of people will correlate innovation with big ideas, complex ideas, right? Solving your Navier-Stokes equation, perhaps, right? Is innovation all about that? The answer is no, and you will be able to see from the examples that I'll be drawing later that innovation can be about small things. The last point that I want to make before we go into the case study is that do not go about looking for problems, right? Many a times when we start some innovation initiative, we get people to say, come on, share your ideas, right? People start looking for problems, right? What I want to say is that problems already exist. If not, there won't be a need for engineers, right? And chances are you are already facing them and you feel for this problem because these are the issues that bite you every day. So do not go about looking for problems, because if you solve an existing problems, it brings you more efficacy, and these are more true to life, and you can kind of see the problem in totality. If you try and look for problems that does not exist now, potentially you will be kind of this will be a pseudo kind of setup whereby perhaps the problem isn't a problem, to begin with, or you do not have a total picture and you are not solving the entire issue altogether. So that's what I want to bring across for now. All right, so now, okay, what's your part in aerospace innovation, right? You will be either solving issues that currently do not have a solution, a real problem, limitation, or it may be because you could not do certain things that you're supposed to do so because of financial consideration, especially in the climate that we are in, right? Or you could be likely, which is more probable, that you will be solving an existing pain, right? The one thing that I would like to use in relation to this is something that those people who practices Lean Six Sigma would be very familiar with, the 7 or waste, right? Likely you'll be solving issues of overproduction, making too much, right? You have too many things. So when you make too much, this thing perhaps may not be used and it goes to waste. The second point about correction, that is very pertinent to aerospace engineering, especially for people in the MRO environment, maintenance and repair and overhaul environment, right? Because sometimes certain maintenance work will require you to have a certain outcome, do this, inspect that, or remove a particular component. And the processes currently may not be ideal. It requires a lot of work, it wastes time, it is frustrating, it makes things non-controllable. You cannot estimate when you can finish the job. The part on inventory also quite related to aerospace. How are you going to manage your inventory such that you have proper track records, control stuff, right? The part on motion, like this part on motion talks about you as an operator or you as an engineer in order to accomplish a certain maintenance work. Do you or does the process currently require to go from the back of the aircraft to the front of the aircraft and to the back again, right? There's a lot of motion. For conveyance, similar to motion, but on a greater scale, usually pertaining to logistic movement, you have to move from one geographical location to another, right? Do you have too much of that? Over processing, that is something also very close to heart, right? In aviation, we have a lot of records. We do recording, we do many layers of checks, right? But the question is, for certain implementation, because of fear, are we doing too much? Doing more is good, right? Doing more for things that does not bring value is not something that we want to encourage here. And in that relation, if you do something that is you do something more but it does not bring value, right? Potentially you are going to tire up the staff within the operational chain, and because things get so mundane, it actually dilutes the importance of a particular layer, right? That is in the process, because people would likely think that they are doing redundant job. People would rely on the next layer, thinking that the next layer will check and find fault if they don't do their job well. So they get complacent, and usually they pay less importance in what they are doing. The last waste is waiting, right? I guess a lot of people who are dealing with the mechanical works of aerospace would understand that there may be a lot of waiting processes, right? Getting approval, or even the maintenance task itself, right? Waiting for things to cure, right? Is there a better way of doing so? Is there a better way of actually sequencing your job such that you have less idle time for the operator? So broadly, this is the idea of issues that you will be solving through innovation likely, right? So now we go into the case study that I have here, the first problem, right? This is an actual problem, right? Before we go into the text, there is a picture on the bottom of the slide, right? That shows a helicopter. And this picture is taken from the internal of a ship. So today, if for those of you who have worked with helicopter on seaborne operation, you would have known that the aircraft would be stored in a hangar, right? Which is where the picture is taken from. And because of the confines of space on board a ship, right? Usually naval helicopters or helicopters that work on board ship can have their blades folded, right? So you see in this picture, right, you have a helicopter with the blade folded. So the problem comes, right? This helicopter that we looked at previously requires a main rotor blade replacement, right? And for a medium lift helicopter, the rotor blades are very heavy actually. So you need an overhead hoist to do the job. Now here comes the problem, right? You have a blade that requires replacement in the folded configuration. It has to enter the hanger in a folded configuration. But when you have a folded configuration, you kind of can't reach the blades because they are intertwined together, right? And you could say, let's do the change or replacement outside. Well, you can split the blades when it's outside, but you won't be able to access the hoist. So it's a chicken and egg issue that we are looking at here. So with innovation, this idea comes from a technician actually, right? Because he knows his craft very well, right? He says that, okay, every time when we replace the blade flow actuators on top here, right, there's a need to off-check this actuator. And in order to do so, there is a pre-existing test set that the OEM has for checking the position of these blades. So the idea came, he said that, well, okay, let's do this. We can use this test set. We can have the aircraft in this folded configuration, enter the hangar, and we use this test set to offset the blade slightly, such that the blade clamps, right, usually attached at the arm of the blade, right, could reach the blade that we want to replace, and we could also use the hoist to bring down the blade. So simple solution, existing equipment without any change or any need to fabricate anything, right? He managed to solve a problem and get the aircraft flying again. All right, the next issue here that we will be looking at is for the idea of correction. Is part of the 7 milders that I shared earlier on. Right, so this is more mechanical, this is more technical in nature, right? For those of us who have worked with a non-fly-by-wire system, you will realize that flight controls are actually made up of many shafts, push rods, and it actually requires you to translate perhaps rotary motion into longitudinal motion. So this is what exactly a torque shaft will do. So imagine this is a picture of a torque shaft. This is in its installed position. So what happens is this is the push rod. When the pilot command comes from the flight controls, this torque shaft actually twists and this is connected to the cockpit below. This is the top of the aircraft. So when the torque shaft turns, it actually pushes this push rod. So there comes a situation whereby we need to kind of replace this torque shaft. And in order to do that, right, you kind of need to take the top away from the shaft. This is the top, right, it's connected to a shaft. How these two entities are mated together is that it actually uses a tapered pin. A tapered pin has got a expanded end, which is the what we call the head. And on the other end, right, is a slimmer end, and it has a threaded portion. You see this picture here is a castellated nut. So as you tighten the nut, right, you actually push the head into the torque shaft to lock it in position. Now, to remove this is a problem, right? Because chances are this thing is not frequently removed. It is force mated, and during the installation process, adhesive needs to be used for waterproofing purposes, right? But when you want to remove them, it makes it harder to remove because the pin will not budge. And the OEM says, okay, in order to remove this pin, connect this black adapter to the threaded end, use a mallet, knock this part, right? So that the pin comes out from the other side. We tried that, the pin refused to budge. And if we use more force, we actually cause the pin to bend, which is a big problem because when you do so and the pin bend, there's no way for you to reverse the geometry of the pin such that it can exit smoothly. And we ended up using a destructive method to remove the shaft, which is very dangerous, right? Because look at it, it's very close to the airframe of the aircraft, and we have a rigging plate by the side, right? If we were to use destructive method, we affect the rigging plate, we technically will have a bit of problem getting the aircraft back into its flight control, calibrated flight control state. So this was a project that is very close to heart. Me and my technician, right? We understood the issue here. We know that, the warping of the pin was caused by the non-axial force that we are applying to the pin when we knock the pin, right? So, and we leveraged on what we know, our knowledge about mechanical maintenance of an aircraft as a whole. And we say that, well, we could kind of adopt something that we use for installation of bearing, which is press fitting a bearing. So instead of knocking, right, we took a C-clamp, we modified it, right, make a hole here, and this is where the expanded side, the head of the pin will go through, right, and we compress the pin, or rather we press the pin, because it's non-compressible, but we kind of press the pin, and with continuous force controlled, right, we were able to get the pin out. We took 6 hours for a destructive method to be applied, potentially, right? But with this method, we kind of was able to repeat the process, and a pin can be removed as quickly as within the next 5 minutes. So ideas like that do help you in your daily lives, gets things moving faster. So after looking at these two case studies, what are some of the takeaway, right? The takeaway that I want to share is that innovation is something that can happen in our daily lives, right? The two issues that we were looking at weren't something that we are looking for. It was a problem presented to us. We were under ops pressure to get the aircraft out, right? And you really don't need big actions, complex science to apply innovation. All you need to know, or all you need to use, is your own knowledge to solve that problem. Okay, like I mentioned, do not look for a problem. They are already there. And chances are, when you have operational constraint, time pressure, it gets your mind thinking more. And likely this is when a good solution will come out. All right, the next part about innovation, right, about leveraging knowledge that I've mentioned earlier on. Most of you are in a tertiary education level, right? Or for those of us who are already in the workforce, we aspire to go for higher degree and certification. Now, a lot of our yesteryear's parents would say that, degree or certifications, passport to move on to the next phase in life. You get you command a higher salary with a higher qualification, things like that, right? But is it true in the genesis of this idea? Is it true, right? Not so, in my opinion, right? Because indeed, when you go for degrees and certification, right, what you get from the process is knowledge, and knowledge is the power to solving problems, because you will know as much as you know yourself, right, by theory or by experience. If you do not know something, right, somebody else have to tell you, or you have to experience it yourself. And in that aspect, education do just that, right? But knowledge is only knowledge without practical use if you do not apply them. So with experience, with education, with knowledge, what you have is a set of tools, right? And in order to make the tool useful, you need to apply them. You need to know your crafts, and you need to apply all this that you know to the problems. And school definitely under that consideration is useful, right? And it is only useful if you use them directly or indirectly. So with that, the part on school, right? There is a situation, or rather an experience I would like to share, right? This is the third case study. I did my Masters of Science in NUS, and during the process, there was a product design module, right, that requires us to step through a design process from your design thinking to your competitive analysis, and to whatever tools that you need to use to design a product. The professor then was telling us that since this was an academic setup, they do not require us to actually have a real world problem to solve. No, we get a student problem and we solve it. That's very much a lot of times the outcome of a education or rather a pseudo assignment, I would say, right? But it is your choice. So my team, right, few other engineers, few other aerospace engineers, we decided that we really want to use this process to solve a real world problem. So we came up with this idea. We say that we have a piston engine that needs to always have its carburetor overhauled clean in a operational environment. So current process, need to remove this carburetor. Look at the op shape of the carburetor. You cannot really hold them tightly to remove the screws on top here or the bolt below here, right? And in order to do this properly, you need to kind of go to a workshop which has some form of support equipment for you to hold this carburetor in place, such that you could kind of remove the fasteners properly. But that poses another issue because of the odd geometry here. You use a clamp, but if you were to clamp it too tightly, right, you will damage the carburetor. And that is again another problem. So we kind of applied the product development process to try and solve this problem. So what was the outcome, right? Simple outcome again, we went through competitive analysis, right, things like that. We have a simple idea, right? So we indeed translated this simple idea into something that is tangible, right? We made a box for that carburetor, something like a transportation box, right? And this box basically breaks into two halves for you to be able to hold the carburetor in place with necessary foothold so that you can kind of use your feet to step on it while you try and remove fasteners on top, right? That gives you a proper holding, but at the same time not damaging the carburetor because you have a conformal shape to the carburetor, as well as the probability of flipping the carburetor around to reach the reverse half of the carburetor. Simple design, and we make use of what is very available to us currently, which is 3D printing to manufacture this. And one of my friends actually also printed this thing in luminous PLA, which is very useful because if you do not have a torch to put here, right, at least it gives you some form of illumination if you're working in a dark area, so that you still can carry out your maintenance with this form of constraint. Right, so we go back and look at takeaway again, right? And like I mentioned, use what you have learned. We have used it immediately for the case study that we have shown, right, to solve problem. And we always have opportunities to apply stuff, right? It can be in a school-based environment or for a particular exercise. You could choose to use a real-world issue and apply to your assignment. And the wonder of this is that likely you would score better for the assignment because you feel for the problem. And not only completing your assignment, because you do that, you end up solving a real-world problem, which is very important. All right, now that I've shared some of these case study or some of the ideas that I have seen or worked on, what are some of the side notes that I would like to share in relation to innovation? Right, we in this world that we are living in, right, information technology is rampant, and we have come a long way in terms of IT. So a lot of times when we see ideas coming out, when I was in the board for RSAF, right, ideas usually get translated to actual things through IT, right? So currently, we have a very good IT solution. One example is your CAD drawing, your computer-aided drawing, right? You have software like SolidWorks, AutoCAD, right? or some of you will be using CATIA, right? Previously, these are software that allows us to do up drawings, but actually, right, a lot of CAD software nowadays do have inbuilt solvers for you to prove your concept, for you to test your concept. This example that I have here is a support jig for an aircraft, right? You could size them geometrically to fit your application, but one concern that we always have is after sizing, does it fit in terms of its load bearing capability, right? So previously, the only way to do it without simulation is to kind of manufacture the product, do load testing, and see how things pans out. But with IT, you could kind of even get this first cut analysis through simulation. So use that to verify your ideas. Right. So again, about information technology, right? We need to leverage computational power for process changes. This is especially pertinent to data mining or record skipping for your company or your organization. Right. In aviation, especially, we have a lot of information. And because we are looking at multiple sources of information along the way, right, we have separate databases. So if you could kind of use this thing properly, right, you could kind of combine all this so that you have a centric data source whereby you can call out information from multiple sources, right? One idea that you need to ask, or rather one question you need to ask yourself is, right, through your workings, are you working for the computer or does the computer work for you, right? As counterintuitive as it may seem, right? Do you end up copying a lot of information from one file to another for post-processing? If it is, right, then likely you're working for the computer more than the computer working for you. And by having a centralized system for you to manipulate data, you get your analysis faster, right? So under the consideration, I strongly recommend the use of IT power databases to kind of get a proper solution or as a process improvement tool. Now, one point to note, the point with asterisk here is that if you were to do this for aviation environment, right? Your implementation must have.
Hi. Hello.
Yes, hi. Right, we shall carry on. Okay, so the implementation must have traceability in mind, basically a bit of a record keeping on who is manipulating the data or who is entering the data. Now, this is very important for the process certification that we will talk about later. Right, and in aviation, we need to be very sure that data is as accurate as possible for continued airworthiness of aircraft. The next part that I want to talk about is somewhat related to IT, right? But this is more of application away from the conventional computer setup, right? To help us in innovation, we need to leverage emergent tools, right, as the carrier of innovation. In recent years, we see a lot of concept to tangible implementation being made possible by all these new tools that we have, right? One of them is what I have mentioned, rapid prototyping. You have seen it in case study 3 that I talked about just now, right? Remember the one that the example that I was showing about using CAD and simulation to do a proof of concept to say that this indeed works, right? For that project, we also leverage 3D printing. This is a 3D printed object for fitting, right? There are a lot of sensitive angles here in this jig, right? If we do not hold this position properly, we will have geometric interference. Conventionally, you would have to make a product out and you try and adjust them along the way. But what 3D printing allow you to do is to quickly manufacture a part that has the same geometry although the material may be different, right? For a jig, you likely manufacture them out of steel, stainless steel. But for this case, it's in plastic, it's quick to manufacture, it's cheap to manufacture. It allows us to quickly check to make sure that geometrically this jig can fit. Even if it doesn't, right, we could easily mark out these areas of interference using very simple tools like markers, and we can make adjustment to it. So especially so for people for products or mechanical products with a lot of angles, which will be harder to kind of measure practically. 3D printing does help us a lot, right? The next part that we could look at as an emergent tool is small computational power, right? A lot of times we have implementation as a logic, right? And translating this set of logic into mechanical implementation, such as actuator movements or certain controls, previously used to be very difficult. The only way out was using PLC controller, programmable logic controller. The cheapest version would have cost you $1,000, 1,000 Singapore dollars, that is, right? Makes the entry gap a lot harder, right? But nowadays, we have things like Arduino board. I myself, I have used one on UAVs before, right? The downsized computer allows you to do just that at a very cheap implementation cost. With that, right, if we leverage all this, we see a reduction time in implementation. It goes a lot faster than to send your drawings to workshop or fabrication and stuff. And because these are translated from the drawing physically, if you do not have a CNC machine, right, it is also error prone. But with all this setup, it makes things a lot easier and a lot faster. So consider using all these tools, or encourage using all these tools as your carrier of innovation. The next one is an interesting idea, right? A lot of times when we do innovation projects, right, a lot of people will be concerned that we do not meet the actual intent of what the current device, although it's harder or more expensive, right? We do not have the resolution. So consider this case. This is again an actual case, right? We have an accelerometer. An accelerometer is a device that picks up vibration. It basically gives you the amplitude and frequency, right? The actual test set costs $20,000. Basically, you put this accelerometer here, right, with the necessary supply and pin out. You wire this thing to the test set. This test set excites the accelerometer throughout a frequency and range, or amplitude range, and it basically tells you whether the accelerometer is working properly or not. The next idea is a very rudimentary idea. You have a shaker or oscillator that excites the accelerometer at a particular frequency and amplitude. You have a calibrated multimeter that, with knowledge of the accelerometer, you could kind of tap the accelerometer and checks its DC as well as AC voltage to see if the accelerometer is working properly or not. So two ideas. One, definitely more rudimentary and losing resolution, right? Seemingly, the one on the right may not be as good as an innovation idea, right? Because you're kind of dropping things, and it's kind of not professional in that sense. But let's look deeper. Yes, like I said, the test set would give you a full spectrum analysis, and the multimeter likely only allow you to test a particular frequency, because the oscillator is fixed, right, at a particular frequency and amplitude. And likely by measuring a DC voltage of that particular accelerometer, you'll be able to know if the accelerometer is working or not. Indeed, loss of resolution as compared to the expensive setup, your boss would have rejected the idea. But let's look deeper. The question is this resolution needed? Right? It will be dependent on the use of this accelerometer and what is in place now. What is in place now may be nothing, right? By doing this rudimentary check as an innovation idea that is a sub-$1,000 implementation, right? You isolate, it is potentially good enough for you to isolate the fault. Yes, granted that the test set is better, right? But there is always this 80-20 rule, right? That, you know, if you could kind of kill 20% of the problem, perhaps a total accelerometer failure, you don't even need to go to test the accuracy, perhaps, right? If it's not used for the entire range, and that may be good enough to solve 80% of your problem, right? Which is accelerometer failure. Again, right, if you want to implement innovation ideas with a reduced resolution, it is very, very important for certification to be carried out, right, for especially for this kind of alternative method, right? So in short, what I want to tell you guys is that loss of resolution doesn't mean that the idea is not good, right? Perhaps it's even a better idea because checking a accelerometer with a oscillator is definitely faster, easier to implement, and of course cheaper. And I meet the intent of checking out the accelerometer. Therefore, I'm preventing waste. I'm using likely something that is pre-existing, and I do not need to spend money to do so. All right, this slide is for people who are working in a innovation idea, right? Or rather driving innovation in the company, right? These are these are criteria that I kind of adopted from my previous workplace, right? But before I talk about them, right, I want to tell you that we shouldn't be quantifying innovation tightly, right? We should not pit innovation to a yardstick always, because by doing so, you will kind of kill innovation because of people having to stick to KPIs per se, right? But nonetheless, sometimes, especially when we talk about return of rewards, there is still a need to classify them. So these are something that you can adopt, right? Whether this innovation enhances work performance, right? These are usually non-tangible in the safety aspect, operational aspect, knowledge and learning, knowledge transfer, application of knowledge, like I said, right? You can kind of quantify them this way. The next two parameters are widely used, right? The part on time, cost, savings, and avoidance. Although widely used, this usually brings about a bit of contention, right? Because people get confused with savings and avoidance. So just take it this way, right? A very good example. I'm a mechanical guy, so I'll draw a mechanical example, right? Saving is something that you expect to spend, and by having this innovation idea, right, this time and money need not be spent anymore. So this is a saving. One very good example is filter replacement on your car, right? You kind of replace the oil filter every 10,000 kilometers for Japanese car. So these are factored into the life cycle of a car. But however, if you are able to find a filter that can last longer, perhaps, right? Not too sure about that, but perhaps last longer. You are changing this thing at every 15 kilometers per hour, 15,000 kilometers. So instead of doing it at 10, you are doing it at 15 now, right? You kind of reduce whatever you have factored in. So this is saving. Avoidance is slightly different, right? Avoidance are exigencies. So these cost or time not expected to spend during the life cycle of a particular machine or product. So things like perhaps induced damage, right? You have a sale that because of the location that it is located, perhaps without the necessary cover, gets damaged easily, right? So sale damage, sale deterioration, yes, we expect them, but damages, perhaps we don't, right? So if your innovation idea solves that problem, right, prevent this thing from getting damaged, right, this is a avoidance. Okay, the next few points are actually self-explanatory. The degree of innovation, whether you kind of get the idea elsewhere or it was something new. Of course, something new will be, we need to reward that something new idea, right? Because these are usually more tedious. The extent of implementation, right? How far is this idea shared across? For example, in a normal MRO environment, you will be working with multiple aircraft type. Is this idea applicable to all aircraft type across, say, the Boeing 777 aircraft? Or is it applicable to both 777 as well as 787? So, of course, the bigger, the better. And the idea about spread is how far did this idea go out of the organization? Who says that it's good, right? Today, you may be working for your company, but what does the OEM say about the idea? So case in point, the spread for the taper pin remover tool has acknowledgement by the OEM. And it was back then when before I left the organization, there were talks about putting this thing for the use of worldwide operator. So under the consideration, the spread will be rather big, right? So again, although I said this point, please do not kill innovation by always having a need to quantify it, right? Because it will kill the genesis of innovation itself. So innovation within the organization, within your organization, what could you kind of look at to promote innovation, that is, right? In order to start innovation rolling, innovative culture is very important within an organization, right? This means that the organization cannot be adverse to change. These are actual statements that I've heard throughout my employment life or throughout my life in the industry, right? People will be telling me things like, this process has worked well for 30 years. Why are you changing it? Or, are you sure? You are doing a change on a flight control system. Now, this is a critical system. Don't waste your time on it because it will not get approved. Or because of the many things that we have on hand, people will say, come on, let's go through the process. We do not have time for any change. These are change adverse, which is not good for innovation. Same issue, take a look from other perspective, right? It could be a case whereby when we implemented this process or this system, it was 30 years ago. System support and ideas weren't as open or as good now, right? It is really good that with all this development nowadays, we could take a look again at it now and we can come up with something new. Or it can be, right? Yes, rightfully said, this is a flight control issue that we are looking at. But because of your idea, we could kind of do it faster and even safer than what is prescribed, right? And you don't go about causing auxiliary damage as compared to the OEM specified procedure. Let's look into it. This is a good idea. We will get this properly certified. The key here is properly certified, right? As with the taper pin tool. Right. So at this juncture, I want to say that more brains, more mind, think better. OEM, although has a very good thought about things, very complete picture of what they are doing, may not exactly have the best idea. And you, as an individual who works in the industry for a longer period of time, may have something even better. So let's change your mindset a bit. OEM is not the best, right? We could work together to make this industry better. The last point that about having a lot of things on hand and not being able to implement certain things or think about what we want to improve. This is also not true, right? There was a case about a electronic prompting system for bench stop control, right? Controlling of where, or rather telling where the operator through visual indication where the stock is in a particular shelf and doing a bit of inventory control. Complex system, right? With Arduino board and whatnot, you need to wire up the system. Takes time, but with this thing properly implemented, right? Let's look at long term. It makes life so much simpler in the long run, right? So with a change of perspective, innovation can be seeded. Same issue, same solution, take a different look at it. Implementation may be easier than what you think it is. All right. That is that is about the change in mindset. Now we look at something more tangible, right? The part about sharing the effects of innovation, right? You could consider as a organization, right, that monetary return, tangible returns, to be given back to the idea owner, can be an individual or a team, as well as a award to say that, we acknowledge your effort, thank you for the good job, please do more, right? So this part on reward, right, I would want to emphasize that it is not a trade that we are looking at. It's not that we are buying the idea from you, right? It is a return that we are looking at, and cost savings and cost avoidance are things that the company have to spend anyway. But because of these ideas, right, this total cost has been saved, right? We are just returning a portion of this to the idea owner, and not a trade, because usually when this thing happens, this is my own experience, right? When we have money or tangible rewards, you see teams going out together to celebrate their ideas, celebrate their implementation. By doing so, you promote camaraderie with the organization, which is a good thing, because it's a positive outcome that you likely spur people to work faster, better, and you form a more cohesive team, right, through this process. The next thing is about shared patents, especially when it's a very good idea that can be cross-implemented, right? Yes, because the employee works for the company, right? The rights usually will go to the company. But one idea to be considered is about sharing patents, right? I have not done that myself, but it will be definitely something that is a very good testament to the individual who actually apply the idea and get something to his belt, right? The next thing that, as a corporation, you could kind of review or adopt is about event showcase, right? Have an event, look back at what was done in the previous year. It promotes healthy conversation. Again, it gives recognition to the individual who have given the idea, right? And we we have this event, and we invite a lot of people to the event within the organization and out of the organization. It will actually get minds thinking, right? It will tell people that innovation is not a big gap to scale, and perhaps somebody else may have similar ideas, right? And because they see that these ideas are implemented, right, it gives them the courage to implement their ideas as well. So annual showcase is rather important, right? In terms of recognition, right, and emphasis of a particular organization on innovation, right? You could take it up to higher level, right, by taking part in international competition, right? We have things like ICQCC that is organized, if I'm not wrong, by the American Standards for Quality, right? TEA is something that is, I guess, more unique to the Singapore context. It's a local event. So when you pit ideas against other organization, right, it goes to show that the organization is committed and is not afraid to showcase innovation ideas. So that could also seed innovation, promote innovation within your organization. I have some important things to share about innovation. I have mentioned this along the presentation since the start, but I want to reiterate them because, or rather reiterate this because it's very important. This is a set event, caution, that we can draw from a previous event. This is when innovation will go wrong, right? We have an American airline, American 191 flight, a DC-10 flight that took place in May 25th of 1979, right? It was a sad event because during the takeoff run, engine number one separated from the aircraft. Basically, what happens is flips from the underside of the wing over the wing and separated from the aircraft. While doing so, other than losing power, it damaged the wing as well as the hydraulic system, right? Aircraft lost control, rolled over because of asymmetric thrust and lack of control, right? And this incident came out with no survivor. The root cause was improper use of equipment, right? Smart idea, right? Basically, we have an engine attached to a pylon, right? And the pylon attaches the engine to the wing of the aircraft. So in order to save time, American back then says that, okay, we will not drop the engine first, then the pylon. Instead, we will use an alternative method to hold the engine in place. We will drop the engine and pylon together by disconnecting the pylon from the wing. It's a lot faster, results in less disconnection of equipment, save 200 man hours for American airline. But actually, by doing so, how they did it was rather they used a forklift to hold the engine in place. But as you disconnect the pylon, right, you actually shift the CG of the engine, right? So it actually caused the cantilever weight on the, or cantilever load on the pylon to wing attachment. So because of the damage, right, there were fatigue damages as the aircraft takes off each time when the aircraft is loaded with the engine power. The failure happened, and this situation resulted. So innovation can be a double-edged sword if you do not use it properly, which is exactly what we see this case, and we want to avoid this, right? And going to the statement that I had earlier on, right? Innovation is really, rather aviation is really a highly regulated industry, and it's highly regulated for the same reason of repeatability, standards, compliance, and qualification, or in the name of aviation safety, right? Very important. Certification is a must prior to implementation of any ideas, right? And we could look at certification from OEM support, right? If you have something that is new, you think that is good, you could kind of write to Boeing or whichever aircraft manufacturer you have them evaluate the idea, right? For in the military context, right, or even in some of the civil aviation context, if the NAA, the National Airworthiness Authority, right, clears certain engineering implementation, what clearance can be sorted, right? And for the case of system implementation process changes, like I say, the IT databases that we look at, right, it must be approved by a quality process within your own organization, be it a Part 21 organization or a CAMO organization. Okay, this part about trial, right, very pertinent in the practical aspect. When someone comes out with a new idea, the first thing is to try, right, see if it works, right? Word of caution, right? Even if you want to do so, this trial implementation needs to be evaluated and approved. Now, because what is unknown is that while your method works, right, there may be hidden issues, either damage to equipment or worse still, causing harm, injury, or death to the person working. This is what we do not want to experience. Aviation is written in blood, as many would say, right? Because it's so new, there are certain things that we haven't seen, and when we apply certain things to areas that we haven't touched on, this may potentially result. But we also have a lot of experience since the evolution of or since the commencement of aviation. So, right, endorsement or certification, right, allows a full-fledged evaluation of the system by the domain expert, right? Like I say, if you are working at a particular level, right, you only know what you know best. You won't know what you do not know. And by putting things to certification or through the certification process, you kind of get more people who have worked specifically on the system to look at your idea, right? So that it can be implemented safely. But if an organization or a particular ecosystem encourages innovation, they look at all these ideas with an open mind, right? Restrictions may be implemented for certain ideas, new ideas at a trial level or at the actual implementation level, right? But always have in mind that this is not to have the idea killed, but more of making it safe. And if this thing can be, if a balance can be struck innovation will be a positive outcome to aviation. So we have spoken quite a bit, right? And let's look at some of the recap, or rather the things that we have spoken about. So in short, right, I think all of you know that we are coming towards the end, right? Innovation may not be a complex idea, right? And it may not need to be complex to achieve a great effect. Start with what you know and start with what you have, right? Apply what you know. Knowledge application, again, is very important, right? These are your tools to solve your problem. Apply your knowledge to solve a problem. Leverage emergent technology, leverage IT to bring your idea across. Be open to new ideas. Do not kill ideas. Do not turn ideas off, because the moment you turn ideas off to an individual once, right, it sends a very strong signal that you're not interested, right? Or whatever new ideas that may come along the way, the individual may not choose to tell you again, right? Because they see no point in doing so. Innovation has its benefit, right? You could kind of share them to put a positive, constructive environment to it. And lastly, like I just shared, certification is very important for the safety of all implementation for all new ideas. So to take note, right? This is very important. Okay, with that, I have come to the end of this presentation, right? I guess the next part will be Q&A, right? And perhaps I could kind of hand the mic over back to Vicky for a while, right? Thank you very much for attention.
Thank you, Mr. Adrian, for the very, very insightful about the innovation in aerospace. I definitely has actually gained a lot on this just by listening to this speech, because many of it is actually very, very relevant, especially when I look at the some of the toolings that you have actually innovated, which I find it very applicable to even our daily work and the problems that we are facing in the actual MRO environment. Now, guys, I will open up to the floor. Probably any guys, any person who have any question to raise, please, you can either type it in your chat box, or you can actually unmute your microphone, and you can actually ask the question to Mr. Adrian. Yes. Anybody, guys, on the floor? I actually have questions, Mr. Adrian. Yeah. All right. The notion of encouraging innovation in working place. Yeah. In the working environment that you have worked before, what are the common challenges? Yeah, that you face and you find it very hard to actually suggest or propose certain innovative ideas. What are the challenges that you face when you want to actually implement a certain innovation in the company that you have worked before? Okay.
All right. To that point, I guess I was quite lucky, honestly, right? During my days in the Air Force as well, currently in Boeing, right? Whereby I was actually subjected to rather an environment that promotes innovation, right? But to that question, right? In fact, we do have issues with some of the more critical systems. Flight control was one of them that I shared, right? There are certain implementation that may kind of leave us more exposed in terms of safety, right? There may be certain form of risk acceptance. For example, if you are servicing a hydraulic strut, right? You could kind of not use a jet per se to hold the aircraft fuselage in place, right? You could kind of deflate the strut using an alternative method, something like that, right? These are risk acceptance, and usually we get pushback from the authority or from the people actually certifying the process. And how do we circumvent this as innovators? I guess it very much boils down to facts, figures, and knowledge, right? So if we were to suggest alternate procedure, we need to show that these procedures are safe, we are accepting risk, and how are we mitigating this? Under this consideration, right? engineering tools come in very useful, other than facts that we can get from simulation, from load testing, right? It will be also things like your system safety assessment, so that you can quantify the risks involved. You can also look at failure effects analysis, right? That is also something that you can kind of list out all the issues that you will face and what are the actions taken to circumvent them. And for those that cannot be circumvented, what are the methods what are the safety measures that you put in place to reduce these issues? Looking at that, it buys more confidence to people approving these alternate procedures, and when it's more thought after for the safety and well-being of the people as well as the equipment, right? I guess that would allow greater buy-in or easier buy-in, and these are some of the techniques that we can look at to circumvent these problems. Yeah, I have a question. Yeah.
Thank you, Mr. Adrian. Do you think that, this is also based on experience. I also had similar experience, like the rigidity of the aviation authority. Sometimes we actually do feel that it may be too rigid that actually we just give up. We just give up implementing or proposing the ideas to some of the authorities. But at least now, you have mentioned just now, there's a lot of work to be done in terms of using your IT tools and generate the models, and then develop the data, and then present them the data and models to convince them that the alternate method should be acceptable. We are also facing this similar kind of a scenario. I agree with very much to what you said.
Yeah, and I would also guess that the challenge with using facts and figures and data is that a lot of facts, figures, and data may be proprietary to OEM, right? And you won't be able to get these to kind of prove certain point. So it boils down to as much as how much the organization want to go, if it's actually feasible. And of course, financial benefits do benefit the company, right? You could kind of consider destructive testing to kind of reverse engineer or certain analysis methods, such as sometimes we want to know material strength and whatnot, right? Dog bone testing or EDX, RDX for you to kind of find the material composition to prove a point. I get your point that authorities may still be very apprehensive in accepting all this. But I guess one way to really circumvent this is to gain buy-in from more major people. Like for example, if a MRO company has an idea, right? If this idea is supported by the aircraft OEM or perhaps other regulatory authorities, right? I guess that would kind of shake them a bit and get them to think harder. Yeah.
Guys, on the floor, any more questions? Who's actually sharing his knowledge and experience on mission. Any more questions from the floor? Any more questions?
Hi, Mr. Adrian. Right. Thank you very much for the motivation on innovation. I think there's good examples provided in your experience. You shared your own experience as well as other relevant innovation in aerospace. For the benefits of undergraduate students, there are few of my undergraduate students are joining this particular course, and there are also few of my PhD students. Probably you can have some tips to motivate them further in terms of why we need to innovate. Of course, from your slides, you have some information on why we do innovation and so on. Probably at their level, at their students level, probably some tips for them to or to motivate them to do innovation. Thank you very much.
All right, hi, sir. Okay. Yeah. In fact, innovation at the academia level or tertiary level, at the tertiary education level is very much important, right? Because yes, we say that in the industry we have actual practical application, but in my own opinion, I would think that innovation can come easier from the academia environment, because first and foremost, in the academia environment, definitely you guys are more receptive to non-conventional ideas, and because you guys are pushing frontiers. On the note of pushing frontiers, regardless if you are undergraduate, a PhD student, which I have not embarked on the route before, right? But I guess every bit of things you do through your thesis research, through your final year projects, they are in some way pushing frontiers, and you hold key roles in whatever you are doing, because small little findings may end up very big in the future. And like I say, because you guys are more receptive to ideas, usually idea generation or proof of concept, new ideas, new novel ideas usually come from the academia. And you guys have the tools, the instrument to actually do all this testing and validation of ideas. So under that aspect, do not, or rather under that consideration, do not think that it's just a final year project, something small. In fact, this can turn out something big. Yeah.
Thank you, Mr. Adrian, for the answers. Any more questions on the floor? Okay, I have one question here. How do actually Boeing collect ideas from the people uh, and put the ideas into their design of their products? Is there a channel, or is there an email address, or is there something that people can write to? Okay, I have this idea. I just share with you one example. One example we had actually, I raised it up to one of the aircraft manufacturers also in the US, but it's actually in the corporate jet. The idea of our galley on the corporate jet is not very huge. They are quite small compared to the Boeing commercial jet, and there are areas that they wanted to freeze or cool drinks to make the hot canned drinks or even their wine.
Ricky, we are losing you. I can't hear you.
To chill it up and all those things. So many of these they are still using this conventional. Okay.
Ricky, we can't hear you. Yeah.
This commercial, this corporate jet, they wanted to have this ice, cold, chill. Hey, can you hear me now?
Yeah, you were breaking up previously. Yeah.
Okay, sorry. Okay, how do you all actually collect ideas from the people to incorporate certain innovation into Boeing products? Is there a channel, or is there an email address, or something like that?
All right. Maybe this is more of a sharing of my experience with Boeing Asia Pacific Aviation, right? Within the company itself, we do promote quite a bit of innovation, right? In fact, we have a annual innovation challenge whereby we look at some of the existing problems that's being faced by the company, and we have a board for people to suggest solutions to all these problems, and the company does put resources to solve these problems. So this is actually at the operational end of the company. At the bigger level of Boeing, right? I have not participated in any, honestly, because we are more towards the MRO end. But for both the Boeing company, right? There are innovation challenges that I've seen before that allows ideas to flow through, right? They do have such entities, but I think more closer to what we are doing every day. In fact, not as a not as a direct innovation idea, but as a solution to solving problems, right? Boeing Boeing commercial airplanes, they do have communication channels for operators, for MROs, for their service support arm, Boeing Global Services, to actually write to people in Boeing commercial aircrafts. So, commercial airplane, that is, right? And these ideas will get reviewed, right, as a solution. And I have even seen suggestions, right, of maybe certain consideration in work processes being implemented into the aircraft maintenance manual by Boeing when they assess and deem that it is suitable. So to answer to that question, right, yes, we do have discrete events for these ideas to be brought up, but actually, more importantly, I would think that it is actually applied on a day-to-day basis. When we have problems, we write to Boeing, we give solutions, and these solutions does get implemented as a whole. And last but not least, I guess we are very closely knitted, or the Boeing company is very closely knitted to the industry, right? There are things like industrial steering committee, whereby the operators themselves liaise directly with Boeing to bring out certain issues that they may be facing, right? So I guess as a whole, for us, there isn't much problem about suggesting ideas in that sense.
Thank you very much for the answer. Okay, guys, any more questions? Any more questions from the floor? Any more questions? This is a very, very, I don't know, this is a very interesting talk for me, actually. Very interesting. Guys, any more questions from the participants?
Not from my side.
Okay. Right. I think it is okay. I would like to hand over the mic to.
Hello.
Yes, please go ahead.
I have a question.
Yes.
Okay, just now, Mr. Adrian, you said if there's any problem issue in, let's say, in Boeing, the operator will know, right?
Yeah, so correct. So if there's any issues that are faced by the operators per se, right, they do have a communication channel to reach back to Boeing commercial airplanes to have their issues resolved. Yeah.
Okay, so my question is there any platform like between the problem faced in the industry with the student itself? I mean, like you said just now, FYP is very important. Because currently what we do in our FYP, we didn't know the problem that being faced in the industry. So is there any platform that you know where the students can see the problems that face in the industry? Do you get?
All right, I get your question, right? Rather, if I could kind of rephrase your question, right? Currently, I would guess that FYPs are very academic in nature, right? They may not be solving a real industry problem, perhaps, right? In your thought, right? So you're saying that is there any channels that you can kind of download problems from the industry, right, and try and put them as your FYP to solve these problems?
Yeah, sort of.
Yeah. Okay. I guess that is a very good point, and I applaud you for having such thoughts, right? Because honestly, like I mentioned within the slide, right, we do not want to solve pseudo problems. We want to solve real world problems, right?
Yeah.
Yeah. So in effect, what avenues okay, first and foremost, problems like that, right? They get handled by the industry, or for example, if issues float to Boeing, right, Boeing would have taken them up and try and solve them. But for your case, to port this across to academic environment, I would say that there are two routes to it. Some of the professors that you will be working with actually has got assignments or projects from the industry. They are funded projects. For example, for my own experience, right, I was involved in Defense Science Organization project, DSO project. DSO is a research arm in the for the military in Singapore. So we were tasked to build a UAV. So that was actually a actual issues that actual thing that we want to do, right? So from industrial projects, likely you will be solving a real problems because they are funded, right? They will not be funded usually for without a cost, right? So there would be a cost to it, and if you want to, you could kind of embark a FYP on such projects, right? That is the first portion. The second portion that you could try to work towards is immersion, right? Immersion is very important. Sometimes problems exist and people don't either have time to look at the problems or right they are so in tune to the system that they actually live with the problem. By immersion, what I mean is that go on, take up a internship, take up a industrial attachment with a commercial company, commercial aviation company. Look at their processes, look at how they are doing things, look at what are their top 10 delay drivers causing aircraft not to go. Look at what are the top 10 tasks that is the most manpower intensive, right? Look clearer, identify a problem. Once you identify a problem, right, you could kind of discuss with the company even beyond your industrial attachment to say that you are interested in solving a problem. Can you use this as your final year project? And of course, you will bring this back for a supervisor to have you supervise for the project. And you could kind of then attain the idea of solving a real world problem through a FYP. I guess that could be done, right? I guess Professor Rahim and the team over at UPM, you could kind of comment on this as well.
Okay, back in Singapore.
Very much.
Back in Singapore, right? So how strong is the relationship between the industry and the university?
Okay. Between industry and university, we do not. This is my personal opinion, right? We do not have many companies working with the universities. Although, right, some of the examples that I can draw are things like the Rolls-Royce corporate lab at NTU, right, whereby they kind of push engine frontiers through the research of NTU, Nanyang Technological University. So that's one of them, right? So this is a corporate lab that we see in NTU, right? Other than that, in terms of industrial support in relation to research or university, we do have an intermediate arm in Singapore, right? The entity is called A-Star, right? They are pushing industrial frontiers through research. And how do they push frontiers through research is that, you know, they will have people with industry experience. They see where they are actually piloting the industry towards. What is the current gap between where they want to go versus where they are now? And they cover this gap through research. And the entity itself does research and it usually gets spilled over to the academia. And under that consideration, right, this is how the linkage is formed between the industrial problem as well as the academia.
Just to add on, I think what Adrian mentioned just now, the key thing in bridging the gap between academia and the industry, basically through relationship. Basically, how the academia, the professors, the lecturers engage the industry people. Obviously, like we have in UPM, we have Mr. Ricky as our adjunct. It's just a bridging what we have in the university and the industry. At the same time, in Malaysia, we have the Aerospace Malaysia Innovation Center that was set up way back in 2011. Is a consortium that tried to bridge the gap between industry as well as the academia. However, it is the responsibility goes back to the lecturers, the professors in the university. They have to make sure they can have good relationship. It's a personal touch. Without being friends to people like Mr. Ricky, now we have Adrian, our friend now, because we are becoming friends. So we can then later engage in terms of trying to solve real industry problem. That is the key thing. The university lecturer must be able to engage the industry. It is not waiting for the industry to come to the university. I think that is the key point here. Thank you, Adrian.
Yeah, and I guess that I guess also students, right, could play a part, right, to help the professors, because like what you mentioned, it will be very tedious to only solely depend on the professors, right, because of the many linkages that you have to form. So students, you could kind of also play your part, right, through the immersion program that you could kind of self-initiate, maybe as a part-time job or internship. Yeah.
Okay, guys, any more questions? A lot of discussion. Any more questions from the floor, guys? Yes.
Okay.
Please
Thank
go
you.
ahead.
Thank you. Very good morning. Assalamualaikum and very good morning, everybody. Thank you, Mr. Tan, for that particular presentation. My name is Rahman. I used to be in academia and then I left to go into industry. And I actually posted my observation in the chat box. One of the major causes of this gap between academia and industry is that both parties speak a different lingo. The linguistic domain is significantly different. See, you're nodding your head. I did not realize that until I went into industry. When I went there, I thought, hey, everybody's in the same industry. Academia should understand what industry speaks, right? Everybody's speaking English. No, there are significant gaps. One example is that academia tends to unpack issues, whilst industry will actually go straight to the point. And this gap, this lack of understanding of how to translate one part to the other, this is one of the causes of a lot of FYPs going into studio problems. Now, we need to actually have a better platform to allow both parties to understand each other. The Ministry of Education did take some initiatives, but okay, since I'm ex-academia, I can say they don't work lah. They don't really work. So we really need to find or rather develop a better platform to help this cross communication. What do you see? Thank you.
All right. I guess I'm not sure, but you could kind of clarify if my what I feel may be incorrect, right? But I guess it boils down perhaps to a bit of a research value that we will be looking at, right? Because like what you say, industry is very fast paced. They want to solve problems at hand, so they dive straight, right? And for academia, I'm not too sure, but I guess there will be a bit of resistance to take up certain things because they may not have some sort of research value per se, right? I would guess that one bridge that we could kind of look at to have the industry speak the same lingo is you need to have a this bridge that has both the academia and the industry people on board, like what was mentioned by some other speakers earlier, right? And I guess a particular context or particular environment that may potentially work is things like mindset in Malaysia, or IES, the Institution of Engineers in Singapore, right? Because these are actually academias that are having industrial experience. So very hard question to answer, honestly, right? Because this is a mindset and consideration issue. But it will be more of, I guess, crystallizing some of the key issues, key problems that the industry are facing. Once you crystallize them, the importance would seemingly go out. Not that it's pseudo, but it's sometimes we have a problem, but we do not really identify or really find the root cause to the problem. So once the problem is being crystallized, the problems are really established, right? I guess the take up would be higher in that sense, right? That's my thought.
Thank you.